购票亭，今天来到蒸汽博物馆，国家蒸汽博物馆，它是属于 National Park 的一种，所以在这边这宾州的 National Park 就不用收费，但是如果要坐火车的话，要买票，一个人6块。只是介绍以前蒸汽火车就是燃煤炭的，现在都是火车电气化嘛。好，那我们要前往去搭火车的地方。哦，这是入口啊，那这入口也就是一个铁道哦，长长的铁道，也是通到里头。哇！我们开了3个小时才到，
超远。
不，中间因为有塞车啦，塞车有事故啊，事故挺多的。好，哇，蒸汽火车哎！台湾是不是还有蒸汽火车啊？阿里山的小火车是蒸汽的吗？但它这个不是小火车，大火车，轻的呢哦。在哪？票在哪？
啊？票。
那上车才查票吗？上面还可以坐人，有小朋友爬上去，卧夫哦，哇，那一天都跑进来了。那我们现在上来，OK， 还可以随时可以开进开出的，这还可以往上升吗？下面验票，就随便你坐吧。对啊，开去哪里啊？没有讲解。 啊。这一路就叮叮叫哦，叮叮车。上面还有一家太近看不见。也是从背后可以看到，还有志工站在这里帮忙。我们刚刚是从那边来的，就开了一点点路，也没有。哦，他开回去了，要把苦回去了。
I'm gonna need you to take a seat, sir.
Okay, sorry. 那都要坐一下。现在巴库到另外一个轨道上。 这样短短的一小段而已啊，就做这么短短一小段。
应该还有其他的啊？
啊？
上次他们做的蛮长的。
对啊，还有做到其。好，走到这就先进来看看喽。这也是另外一个火车头啊。
The tender is a supply car. It is not as tall or long as the locomotive and has two sets of wheels at its front and its back. The coal is stored in the center portion of the tender, piled high above its side walls. Water is stored in the hollow walls.
Colin, stand right here for a second.
这里的火车厢可以上去参观哦。我们上去看一下。刚刚我们也是走这个，这感觉像西部牛展，荒野大镖客。这就是车厢内部的构造哦。哇，工具就对了。这个是。
他是住在这里面的。这是一个工具桌。
这就是那个
stove，
烧铁，就是取暖啊，可以烧，
可以煮饭啊，
可以煮东西。哎呀，失焦了。啊，2层，就像刚刚那个一样，上面可以坐。车厢啊，小小的，可以开吗？不要乱开，挂火车头的地方。
Much more than coal. At first glance, many kinds of freight cars may look alike, when in fact each is designed to fill a need. They have one thing in common: the arrangement of the two sets of wheels, or trucks. If your cargo must be protected from the weather,
水疗管三温暖浴的味道，就是那种 Pinocchio 的味道。
But also needs the fresh air, food, and water provided by a stock car. You might want to carry something that's too big for a boxcar. For that kind of load, you'll need a flat car. But if you have something that might fall off a flat car, a gondola car is the perfect choice because it has size. And all over the car, room in a hot car, soft size and breadth. Of course, these things you will carry some of their own
会是这个就是扇形，就是火车保养，然后把它，它叫 roundhouse。所以这个还有在用啊，还可以闻到那个机油的味道。
这样走。
现在有工人现场维修保养。Boeing 26.
I know exactly what you mean, but things are changing, though. But in a good way, though. This stuff, well, I can't say much, you know, but in a positive way, there's stuff going on behind the scenes.
This is the first train I've ever I'm sorry, nothing even close. Not even close to the first train I've ever That was the first train. Okay, everybody got to agree. That was the first train that was ever made. There's no bell. There's nobody.
That one there was Erie. Then it went to a short line in New York called Dansville Mount Morris. And then it came down here and they renamed it Black One.
They rename it.
So they are still using these things, or just for show?
Just for show.
Just for show. But the gentleman just the guy who just
those
fixed.
two there were. I volunteered at Steamtown. Both of those were running.
Okay.
And one came in, it needed a couple tubes replaced in the boiler. Had 1,500 hours. The National Park Service here let the hours run out because it was a Canadian engine. F. Nelson Blunt, who started Steamtown up in Vermont, the reason he had Canadian engines, they were still the only ones running steam, and America was into diesels. That's why there's the steam engines in Canada.
So you mean their system is different in Canada?
Yeah.
So they
were running steam. America's switching over to diesel.
Okay.
Oh, what is that?
Okay. So now they run by diesel.
Yeah.
Okay. How about the one we ride on the one train, and they have a lot of steam.
26.
Huh?
The Boeing 26.
What?
The
Boeing 26.
Baldwin 26. Yeah, that's here.
Yeah. So it's also run by diesel.
No.
Oh,
They have diesels here. The excursions out of the park, like to Moscow, Toby, Goldsboro, Cresco, Stroudsburg, like that, and Watergate, run by diesel. But if they're going to Carbondale, they'll use the 26 or up in the valley, closer.
Okay. Thank you.
You're welcome.
但是那个是，刚我们做的是用是还是煤矿，但是那个的话是diesel。他是说他是从
它是煤矿啊，
煤矿，
然后它的什么东西坏掉了，要换要15,000啊，15,000块。然后国家就不想
花这个钱。
你要比如说像他们是义工，我们不对这
有兴趣的，对，
他就会觉得
很可惜呀。
然后他才说
就那个是煤矿的，但是那一台也是可以用低手的，加拿大来的，对。
有那个心，尤其当你活到那个年纪的时候，感受会特别的深。没错。
我刚才不好意思拍他，你知道吗？不然应该就记录他讲的话。
老了不重用了，
对，
就什么都不用修了那种感觉。
对啊，就刚刚那位义工，他曾经在这里做过，然后他就说，这些火车因为修理的费用昂贵嘛，所以政府或者是当地的政府也都不愿意修缮啊，可以理解啦，因为要花钱嘛。但是因为要维持这个都不简单呐、你看一张门票6块钱一个人，
他还没有要求你要门票，
对，
就是用那个让你
对，好像是抖内那种感觉啦，嘿。
所以本来是付一钱。
对，反正看这个都就基本上来参观这也都不收费了嘛。对啊，那一张门票坐火车的票6块，也算是以美国的消费来说算是很划算的。好，那我们就从另外一个门出来。那我们要再走进去吗？看一下这里。所以这里曾经都是真实在使用的火车站维修站了，但现在就变成了观光的景点了。这跟就在台湾的那个火车一样嘛，就是你看这个扇形会转的，就可以把火车给送进维修厂里头。还是很多观光客络绎不绝的来访啊。今天是星期六，天气也风和日丽的，所以很适合出来走走啊。现在是秋天了，秋高气爽，外面也都慢慢的景色变了，那个树叶都变红了，所以要看那个枫红的景象，也不一定要去加拿大。有人在敲铃，这也可以敲的啊，你可以看得到吗？拉近一点，这是可以敲的。Exit.这是火车，不知道哪里才是入口。这个马桶，提供热水的地方。哇，这是什么？这个是邮政火车， 就是专门运送信件啊，或者是邮寄的包裹。这是在很久以前的事情了，至少超过半个世纪以前，1950年之前。刚才看外面的指示是说，1950年后引进了柴油动力火车，所以就蒸汽火车就渐渐被淘汰了，因为维修也不方便嘛。所以刚刚碰到的那个一个义工就说，现在这边想要维持这个火车都是不容易的，因为要花很多钱嘛。那大部分的这个商家也都不允许嘛。不是商家，这个政府啊，不允许，就太多钱不划算了，应该这么说，不划算。很漂亮，这里头，它还是维持得很好。对啊，看这也很漂亮。
以前就他们以前就真的很先进。
这就是邮政火车啦，United States Mail Railroad Post Office 1100。啊，你看外面很多行李箱啊，它就是等于是有点重塑当时的场景这样，一个行李箱。然后这个是什么？锅炉吗？这不是锅炉，这是什么？看起来准备吃的地方。就是像卧铺这样吧。可以洗手，有水，然后有房间，里头有马桶，有个马桶，这样看不出来，有个马桶。然后进来就是一个餐桌，啊，在火车上用餐吧。还有这个碗柜。那个桶子像是以前就是装牛奶的，这个应该就是厨房了，然后有睡觉的地方。这个大概就是当时的头等舱吧，我猜。哦，大家一直冲着进来。好吧，那我也就从另外一头过来。不行，这样还要再绕回去。哦，这边还有一个房间，那个房间可以看到不同的房间。Thank you。不同的房间呢，厕所。等一下再过来拍。有沙发，还有房间呢。 上下铺哦，上下铺，你先看到。那厕所你看得到吧？哦，很酷哦。还有每一间厕所，还有马桶，它是相通的。哇，卧铺啊，就在火车上，应该摇摇晃晃的吧？那台湾就没有卧铺，因为台湾一下就到了。最长以前坐夜车，小时候有跟阿嬷坐过夜车，很久，但是也不需要。啊，突然要开始，那在哪里？
突然要开始了，在广告。
OK。要去哪边？哦，这就是国家蒸汽博物馆的内部的门口，但是它被山围绕的是很漂亮的。可以看看，拉近一点，拉近一点，对，就拉近，看到一棵树而已。然后现在大家就待在门口排队等着导览。那国家公园的那种，譬如说导览员或服务员都是穿着这样绿绿的。好，我们就再等一下喽。
Someone your reform so I can see all of you, because there are indeed a few. So, you don't have to. So it's going to be an hour-long walking tour. With between the first 10 to 15 minutes, you are free to come and go however you please. It will only hurt our feelings a little bit. However, after we reach a point called the point of no return and walk through it, you are stuck with me for 45 minutes. Once you go through that gate, there really isn't a place to sit, there really isn't a place to fill your water bottle, there really isn't a place to use the bathroom. So, just know your personal limitations. Once you're through that door, there's no really turning back. If one of us gotta go back, we all gotta go back. In this tour, I'll be assisted by Ranger Chris. Everyone say hi, Chris.
Hi, Chris.
Thank you. He's used to it from AA. So, I'm sorry. So, I want to make sure you all know what you're signing up. So the way we sort of divide this tour up, at least I do it in 3 separate sections. One of which being the turntable, one of which being the roundhouse, the one which being the actual machine. Oh, sorry, almost forgot. Once we're actually in the machine shop, there's going to be a yellow line. We kindly ask you stay on that yellow line. Why? Because if you wander off, people like to lean. If you lean, you get machine grease on your clothes, and trust me, it does not come out. Secondly, when people lean, they love to use their elbows, and elbows love to find power buttons. A lot of the machines back there do still work. And you turn it on, we don't want you to become part of the exhibit, because a lot of paperwork for me and our museum curator. Also, a thing that I have in the shop itself. Why? Because that's sort of how they would be separated when they're actually doing maintenance. That's how we're going to separate it to actually inform you about it. So, any questions about what I've said so far? Any comments, concerns, anything? Perfect. So now I'll bring you over to that first step in our tour. Yes. Yeah. And now I'll lead you to that first step of our tour.
Can 现在跟着大家进行导览。
Can ride a bike around the station.
turntable. Why? Because it's very important. I picture the turntable as sort of the heart and the rail coming out of it, the veins and the arteries of the railroad itself. It's pretty the center of the circulatory system of the railroad. So, whenever a locomotive would be sent out from the roundhouse or brought in to the roundhouse, it is spun on this turntable. This is not the original turntable for the site. The original turntable for the site was built back in 1853. You know it's old when it starts with an 18. And that's over by where currently the Scranton police station is. Eventually, a new one was built out here approximately 1902 and later expanded in 1912. Similar with the buildings here. There were some buildings before, but they were knocked down and rebuilt in 1902 and then later expanded in 1937, of which I will show you what that expansion was in a little bit. This turntable does still work. This works on a 7.5 horsepower motor. Picture a push lawnmower. We still use it. We use it every single day. We bring a locomotive out, we bring a locomotive in. It is controlled by a structure called the doghouse, which is that small little shed up there. In there is a control panel that controls the speed and direction which the turntable turns. Our turntable is powered by electricity, as it was later in the railroad, but that wasn't always the case. Before electricity, it was pneumatic powered or steam powered. Well, for that, it was animal powered. Picture beasts of burden like oxen, mules, and those big pack animals. Before that, it was people. Those are called Armstrong turntables. There's big beams through the middle. People just grab it and push or pull. Great for their calves. Now, approximately whenever a locomotive finishes a run, which is roughly 100 to 150 miles, is brought into the roundhouse. Why? For general maintenance. Now, it's a very short period of time. You know, cars is more like a few thousand, you have to do that. For locomotives, it's that 100 to 150. Now, why? Well, because there's a very thin line between a steam locomotive and a pressure cooker bomb. And that line is 1-inch thick boilerplate. Secondly, it is a massive machine made of metal.
他说这个叫什么 turntable 啊，就是现在还在使用，但是现在是用电的，以前过去是用驴子啊，用螺啊在拉，然后我们到新一个点了。所以说想象一下，在以前的时代都没有电的时候，都是用受力啊，刚才就在这坐火车的。
One of which is given a lantern, a ball peen hammer, and sent under. Now, it's either the youngest person or the guy that pulled the shortest straw. Why? Well, because the youngest person still had their hearing. Why'd that matter? Because that ball peen hammer. When they went down there, they'd hit different pieces of metal to see how it sounded. Why would they do that? It's a way to determine if there's any damage to a metal without thoroughly expecting it, or if it's something that's not visible to the human eye. So if you hit it and it rings sort of like a bell, known as ringing true, there isn't any sort of fracture or damage into it. If you hit it and it gives more of a dull thud, that means there's either unseen or small hairline fractures or damage in that part, and multiple of those parts together are like that, they have to be replaced. Why? Because preemptive maintenance is better than derailments. If they take that part out and replace it, that means you're not risking that part breaking, resulting in a cascading failure, possibly resulting in either getting stuck on the line or toppling off of the line. Not very useful. It's better to fix this than deal with a derailment. The rest of the people would go around the locomotive, make sure everything's tight, every bolt is tight, every pin is in, everything that can be lubricated is lubricated. Why? Lubrication means the parts are going to go longer, saves the railroad money. If you gotta make sure the bolts are tight, then make sure they're not going to pop off while they're in operation. Same with the pins. That's another reason.
导览呢？对啊，通常导览要很多钱呢。
对啊，没有全听懂。
对。
因为
太难了，太快了。
But when you're coming down from pressure, that's pretty much just releasing the valves like that. But as it's going, we still have the engine. Shave down our wheels. Do the blade right behind that one, blade right behind this wheel, and it spins horizontally. It's a horizontal blade, essentially. So, it spins, you apply the blade onto the metal, and it shaves away that material. Now, why would you need to do that? Well, it's for general wheel maintenance. Wheels, like picture car tires, eventually, after use, the treads wear down, they go bald. A similar thing happens with locomotive wheels. But instead of going bald, they develop something called flat spots, which are imperfections in the circle of the wheel, which are flat spots in the wheel. That results in a bit more of a rocky motion and it makes it a bit more inefficient to actually operate the locomotive. So they shave that down to really get into that circle. What also happens if you have to throw the train to emergency, you get a very large flat spot. Say you're going 50, 60 miles an hour, getting a few hundred tons of cargo behind you, throw it into emergency, the wheel stops spinning but the train keeps going. It doesn't care that you want to stop. So as it's going, the wheels aren't turning, which means it's grinding away on that material, resulting instead of a circle, more of a half circle, weird oval shape. So what do? You can't really operate with that, because like a flat tire, you get more of that thumping motion, and that could result in a derailment, which you really can't use. So that lowers. Now, this was either a very bad flat spot or a very bad machinist. They won't tell me which. This one here is a bit more average, but still kind of large for dealing with general flat spots. Now, why did the shaving amount matter? Well, legally, the railroad can only shave off a certain amount of material before needing to replace the wheel. If they replaced the wheel earlier than they would have, if they would have needed to, if your expertise was bad, that meant you cost the railroad money. The railroad doesn't like you costing them money, so you lose your job. So they are very good at shaving away just enough material that you need to actually keep it operational. But let's say hypothetically you're using your wheel and just normally you're shaving it off optimally, but eventually the material gets low enough that it needs to be replaced. What do? Well, you pop it off and put a new one on. What do you use for that? It's called a wheel press, which is the machine behind you. This one still has Canadian anchors. And here's our wheel press. The majority of this machine is underground underneath these plates. What this does, you hook up your axle with the wheel on it, into here, hook it up with the actual chains, hook up the wheel, we're going to pop it off, and turn on the hydraulics. This here it extrudes not 2, not 4, but 600, up to 600 tons of force to actually pull or push off this wheel. What's steam drive wheel tire. Now, steam locomotives were a lot more costly to actually make the wheels for and a lot more complicated, so they didn't just have the wheels you would have actual material shave off from. They would use tires. That way the tires get degraded instead of the actual wheels they sit on. Now, technically, it's not exactly that length, or it's that diameter, it's the 72 number I gave. Tires are actually ever so slightly smaller than the wheels they're designed to go on. Why do we do that? Well, it's based on how we actually put tires on and off, and that's using heat. We use a machine for that, something called a Italian machine. We'll describe it as a machine called the Ring of Fire, of which we do have one on site, and I will go point it out on the other side over here. Any questions about this while we're still here? Yes?
So you talked about these machines being used for restoration.
Yes.
Are they currently being used today?
Not currently. Currently, we're not using the wheel lathe because they tried to install a computer on it and failed, and we have to fix that back. And we haven't needed to do any of the actual like wheel replacement stuff like this in a long time. It has been used, not since I've been here. But these machines right here are not currently. The one next to it over there, that one was used a few days ago. The King machine is still constantly used. I'll point that one out and I'll explain how it's being used. Much more of the smaller machines are used. Little holes in the hose. Then you apply compressed air so it can feed and actually become a blue flame instead of a red flame. That blue flame will heat up the steel on the tire, and that heat causes metal to expand. It is now bigger than the wheel it is sitting on, so you can get it off and it rests on this bracket. Then you can cart this bracket off, or you can cart the tire off the Narnia, or whatever you want to do with it. You bring your new tire over, you heat it up to approximately 300 degrees, and you get it back on. And you allow it to cool. It cools, it no longer is getting that energy from the fire to be expanded, it goes back down. However, the wheel is like smaller than the tire, and it wants to get back to its original shape, but can't. And that compression and that friction is what keeps the tire on the wheel itself. It's kind of hard to see the difference between the tire and the wheel here. There's a better one I can point out later. But yeah, that's how this would be used. Currently, it's covered a bunch of soot from when we do it for demonstrations. There's some example of But what I love to talk about here is this machine right over here. Sort of this picture maybe like about the reddish out here, just so I can fit more people in. This right here is, I love to dub the King, also known as our King vertical boring mill. Technically it's a dual bore. This can handle a 7 foot tall piece of metal, can bore 6.5 feet deep into it. What was being used for was the bolster, or a bolster for 3713 when the locomotives were to restore. That bolster was finished. It's over in the welding room currently. Another bolster is going to be put on here and worked on again.
What's a bolster?
It helps support the weight on the tender frame of the actual tender. We used to have a schematic where I could show people, but it's no longer exists here anymore. But it does still work. I have a video of it working if anyone wants to see it on my phone from when we did Railfest. We did demonstrations today. Now, this is a very large machine, so and also very heavy. So heavy in the fact that it can't go on a truck flatbed. So large in the fact that it can't go in a train cargo car. So how to get here? The answer to that is pieces. Imagine a 20,000 piece jigsaw puzzle that spins. Kind of complicated. However, when we received this machine from the DoD, we actually had a lot of either volunteers or employees here that prior to U.S. military service that had worked with these machines before. So they taught us how to put it together, helped us put it together, and taught us how to actually use it. That's a big part here at Steamtown, actually passing down that knowledge. We don't look like a typical national park, right? Typical national parks, you picture greenery, wildlife, stuff like that. We got a lot of groundhogs in the parking lot. But that's not what the National Park Service is. National Park Service is preservation. And what are we preserving? We're preserving the actual locomotives themselves, so you guys can ride it. And also the skills to both operate and maintain those locomotives, which a lot of you don't really think about. Even just being this archaic, but like pre-computer machinist is a skill that's dying in the US. Those don't exist anymore, really. These you have a lot of CNC, computing, and all this is kind of taking over the job of what a machinist once was. And that's something we're trying to preserve here at Steamtown also. Any questions about this? Awesome, spectacular. So, I'm now going to bring us into the next building over here, and you see a lot more of the actual restoration projects. Also, if you've ever really been to the wood shop or had any of those classes in school, a lot of our toys are just bigger, bigger versions of that. But why do I stop here? I stop here for this, which I lovingly call our piece of junk. However, it is not just a piece of junk. This is the original piston for the Ball 126. I say original because it's not the factory original piston. It's the original piston that we received when the Ball 126 entered our collection. Now, why is it here, not the Ball 126? Long story short, it broke. It wasn't set right, and when it was operating, it was scraping the actual piston head and kind of damaging the housing instead of just going back and forth and grinding away in the piston rings. So, with the National Park Service, we want to fix things, and we did. In theory, this could go in the Ball 126 today if we wanted to. Now, why is it here and not in there? Long story short is we don't know how long it will last. It could be 5 years. Our best estimation is 10. Could be 5. Could be 7. Could be 3. Could be tomorrow. We don't know. And so because of that, the piston actually wasn't put into the Ball 126. We had a new piston made, touched. Is that still the original ship that Theseus sailed? And at what point, if it isn't, at what point did it not become the ship that he sailed? We're to that same problem here. We have our Ball 126. In order for it to ride, it needs to be safe for you guys and safe for us. We have to replace parts. We have to get parts up to code for modern day standards. So parts have to get replaced, parts have to get made, parts have to get put in. Eventually, all those parts are going to the original parts are going to be gone, and new parts are going to be in the locomotive. Is that still the original Ball 126? The answer to that is no. We fail as a national park. Because the job of the national park is to preserve in perpetuity forever. If that isn't, then we failed. However, I argue it will never be that point. Why? Because we use similar machines, techniques, and materials, as if that specific locomotive had still just been operating for the railroad anyway. When we got it, it wasn't factory new, original, pre-mint condition. It was a workhorse. It was used, it was replaced, it was abused. And what we're doing it is treating it in kind of a better, but a similar way, as if it had just been being used for the railroad. Eventually, this stuff has to get replaced. It doesn't make it not the locomotive. A second problem we face here at Steamtown is that our parts go extinct. Imagine they couldn't put light bulbs in Thomas Edison because they ran out of Edison light bulbs. We run into a problem here. One problem is that we need a stoker for 3713 to get it to work again. A stoker is sort of an automatic coal feed system. Houses don't use stokers anymore. Houses aren't heated by coal anymore, so no company makes them. I can turn that into the stoker for 3713. I point that out because one, it's a unique problem that Steamtown faces, and two, because of the ingenuity of our shop staff, and I believe that deserves to be pointed out. Any questions about this little part of my thought? Awesome, spectacular. So we're going to move on to seeing this locomotive. Now, because of the size of the group, we're going to go into front of it. Here's what I'm going to do. We're going to be heading back that way.
来一个工厂。
This right here is an old diesel engine, roughly from 1953. This engine is not ours. It belongs to one of our partners, the Anthracite Historical Railroad Society. And why is it here? It's not ours. Well, it's because they're one of our partners. And we have similar goals in mind, so why are we going to get in each other's way? We actually help each other. We provide them a spot here to work on the locomotive. They provide their own labor, tools, and materials. And the plan is to get this up and running. And actually pull excursions here at Steamtown. Like I said, we have the same idea. We have the same ideals. We don't get. This right here is the Ontario and Western 105. This is a 44-ton diesel switcher engine. This was used to break apart trains and make new ones, stuff like that. It was designed to keep the yard. This also is not one of ours. It belongs to the Ontario and Western Historical Society. But why do I stop here? Well, this is where I do my diesel talk. This is where I explain how diesels work. Now, I'm not an engineer. I'm not a mechanic. If anyone here knows more about diesels than me, feel free. I've been corrected by a 12-year-old before. I know humility. So, if you have anything you want me to add to my talk, please let me know and I will add them for the future. So, very basically, you have your prime mover, which picture a car engine block. That's what these look like right here, the fans and everything attached to it. That's where all the piping goes through, everything attaches. That's the main sort of body block of the diesel engine. On top of it, you see those little sort of gray rectangles. That is where the power assemblies would go. What are the power assemblies? Well, they're on wooden pallets right behind you. Those little sort of black cylindrical shapes, picture each one of those as a car engine. That's where the piston is, that's where the compression happens, that's where the diesel fuel is put. Diesel fuel is put into the power assemblies, the aerosolized diesel is then compressed. That compression generates heat, and that heat causes the diesel to combust. Diesel combusts, it expands the gas and moves the piston. Now you've converted the diesel chemical energy into mechanical energy. The piston movement then goes into a crankshaft inside the prime mover. That converts mechanical energy into rotational energy. That crankshaft then goes directly into basically a large alternator. What does an alternator do? It turns that spin into electric current, specifically AC or alternating current. That is then converted into DC current via a converter and sent into a traction motor. What's a traction motor? Well, that is, once again, right behind you. That large sort of black brick with 2 wheels attached to it. Electric current goes in there, basically a large electric motor in there. It takes the electricity, it starts spinning, and that's what makes the locomotive move. Short and sweet. Bit complicated, but diesels are complicated. Trains are complicated. Diesels are less complicated than steam. Typically, comparing them to steam, diesel only spend about 20% of their life under maintenance instead of 50%. They are a lot cheaper to maintain because they introduce something called standardized parts, which means parts can be interchanged between locomotives a lot easier. And you can have a large warehouse on site, so a large machinist crew. To put that into perspective, during the heyday of steam, this site had 5,000 machinists. After diesel, they had 500. They cut 9/10 of their machinist workforce. And also, a thing I like to add is that they were a lot easier to deal with their fuel logistics. What I mean by that is that all you care about for diesels is there a diesel tank where I am? How far does my diesel tank on board take me? And is there a diesel tank where I'm going? That's it. For steam, you gotta worry about water quality, coal quality. The atmospheric pressure affects how well water boils, fun fact. And the railroad guys do that. You also have to deal with maintaining waterline infrastructure across multiple rail lines. Because water and coal were consumed at different rates, you actually had to refill on water across the lines if you're doing a longer distance trip. So, you no longer had to maintain that infrastructure, you no longer had to worry about all those logistics, you no longer need to own the coal mines, because eventually that got broken up, and that's another reason why they switched to diesel. So those are the 3 primary reasons I talk about why they switch away from steam into diesel. Another thing I'd like to add is technically they're purely diesel engines, they're diesel electric engines. I love them, call them the world's first hybrids. The actual battery bank for this one would be right down here. You can see where the 2 cables were connected through. Any questions about diesels or anything I want to add to my talk? Perfect. Now, you're all here at Steamtown, you're not here at Dieseltown. We're not Dieseltown just yet, so I'm going to bring you over to our steam locomotive, more part of that.
I mean, they'd be like 2 hours away from each other again. Well, no, not even. Because it was the New Haven. But they can take the train to the city if they ever want to go. A little excited. Do you like it?
For this, because of the volume of people we have, feel free to step kind of off the line more towards that fence there. Just be careful because there's a little bit of a drop. I have almost tripped there before, so just be mindful. If you guys want to scooch in more in the front here, feel free. So these right here are the drive wheels for the Boston and Maine 3713. These are 80 inches in diameter, but down to perspective, I'm 5'7". Also, the wheels in the Union Pacific Big Boy are 68 inches. They are a whole foot smaller in diameter. Why? The purpose of the engines. Larger wheels mean passenger engines. Why? Now we get to, once again, to circle magic. So, you have one full cycle in your piston, whether that's 2 or 4 stroke, I don't feel like getting into today. But that results in a rotation on your axle. Your axle rotates, it also rotates your drive wheels, which means the locomotive moves the circumference of your drive wheels. Does anyone here know the formula for circumference? That's pi, close though. 2 pi r. Which, I don't gotta do the math, I did the math already. So that means the circumference of these is about 250 inches. I'm rounding because I don't feel like giving exact numbers here. The big boys is 210 inches. This means this moves 40 inches farther in the same amount of time. To move farther, the same amount of time means you're going at a higher speed. Physics. This is where I can more show you the difference between the tire and the wheel. The tire for this, I'll show for your side too, is this distance right here. And for you guys, it's this right here. And the wheel is this right here. They're made of different materials because the different materials have different physical properties. One's cast steel, one's forged steel. Do you know the difference between the two? No, not metallurgist. But cast steel is a steel poured directly into the cast, while forged steel has more kind of maintenance or more kind of stuff done to it. Any questions about these drive wheels? Yes.
And how much they weigh?
I do not know how much they weigh. Chris, do we know how much they weigh?
Enough to break your foot.
That's a good answer. I like that one. Yes.
Are you ever used this for a steam locomotive?
Yes. Of which, once we're done here, I'll actually bring to the locomotive that these wheels belong to. Any other questions about this? For this, you will not come off the rail path. Do not stand off the ramp. Stand here between the actual car and rail. We have a lot of people, so we're gonna have to make space.
Wow, 大一个，这是什么？
You see the actual schematics for the boiler right here. Hello and welcome to the Boston and Maine 3713, also known as the Constitution, named by James Schumann Moore and lovely called Connie by us here at Steamtown. Now, she was built, it is very rare to see a named American locomotive, more of a European English thing. So why is this one named? Well, it's mainly based on when it was built. This was built in 1934. If y'all know anything about the US in the 1930s, not a great time. As the midst of the US Great Depression in 34, and the Boston and Maine Railroad wanted to drum up some positive PR, wanted to boost ridership. So what they do, they open up an essay writing competition in a bunch of the middle schools up in New England, because it's Boston and Maine. And who won this one was James Schumann Moore. Now his essay, you might picture multiple pages, paragraphs, eloquence. Well, it was about 3 sentences. His essay was, the Constitution is the backbone of America, and the railroads are the backbone of this country. Thus, she should be named the Constitution. And that's what won. Better than I could have ever written. Other similar names that I believe won for other locomotives was the East Salem Witch and the Camel's Hump, based on the way it looks. Exactly. She right here is a Super Pacific type locomotive. What does that mean? It means she has a Pacific type wheel alignment. That means 4 guide wheels, of which is right over there. Guide wheels are for taking turns at higher speed. You have more guide wheels. Typically, you have a passenger would have more guide wheels to help take those turns while going at high speed with people. It has 6 drive wheels, which you saw back there. Those to generate the actual motion of the locomotive. And it had 2 trailing wheels, which are somewhere in Narnia, I don't know. But they would sit underneath the firebox, to help support the weight of the actual coal inside the firebox itself. But I did say Super Pacific. That means she has all the bells and whistles, literally, and is superheated. That means the steam is basically run through the boiler again via something called superheater tubes.
所以感觉好像那种仓库有没有？漂亮。 了，演讲讲完了，导览导完了，要带我们出去。来，哦，蒸汽室。
哇哦！
就是刚刚我们有看的那个，然后最后一个连接的地方这样子。然后这里就是可以拉的，这里，这里啊，你要不要拉？你要试试看吗？
试试看啦，还蛮重的耶。还没拉好。
啊，这就是产煤的地方啊，煤炭、煤。
你这边下去。我们走错方向吧？
没有差。好，790号。做得很真哦，栩栩如生。Brakeman and switchman. 这个是 Trolley 博物馆，就比较小台的，像叮叮车这样子，但是你看还是宽轨的，大。这很像我们的自强号呢，莒光号，这比较像我们莒光号。这么大一台车也是叫 Trolley 而已哦。对啊。